for the upcoming operational era of spaceflight, when Columbia will launch into Earth orbit on a routine basis. An ongoing task on all 4 missions of the flight test program was to evaluate living conditions on board Shuttle. Items included food preparation, use of a food warmer, a freezer on board Flight 4, and eating in weightlessness. Personal hygiene tasks were evaluated. As were sleeping conditions, use of sleep restraints, and a sleeping bag. Astronauts also evaluated the effects of exercise in 0G. This unique device, designed by a fellow astronaut, allowed the user to monitor his own heartbeat while jogging. Alternate methods of anchoring oneself in weightlessness were also appraised. Very busy schedules are forecast for upcoming shuttle flights, when crews will be comprised of at least 4 people, including women. Procedures on the ground are being streamlined for the operational era. Processing time was cut in half during the orbital flight test program. Presently, it takes approximately 13 weeks to prepare the space transportation system for launch. It is projected that by the mid-'80s, there will be 2 shuttle launches per month. The number of people in mission control is gradually being reduced. Some positions have been eliminated. Others have been consolidated, which represents a clear indication of confidence in Columbia's systems. While this monitoring is being streamlined, payload monitoring is increasing. A new area called the Payload Operations Control Center was activated during the orbital flight test program to give mission controllers, payload managers, and commercial users the opportunity to develop monitoring and data acquisition procedures for upcoming flights. Experiments in life sciences were carried on board Columbia during the orbital flight test program. A preliminary study of lignin growth in 0G was conducted. Lignin is an indigestible skeletal substance which promotes strength and upward growth in woody plants. It is hoped that in the absence of gravity, woody plants might not need to produce as much lignin, and instead will produce more digestible nutrients such as carbohydrates and proteins. the effect of weightlessness on some flying insects, bees, moths, and flies, was studied. The project, conceived by a high school student, was one of 3 experiments flown on Columbia as part of an annual science competition co-sponsored by NASA and the National Science Teachers Association. Equipment to process materials in zero gravity on future flights underwent initial testing during the orbital flight test program. The monodisperse latex reactor made polystyrene latex microspheres to determine if large identical-sized latex microspheres could be manufactured practically and economically in space. Presently, large microspheres cannot be produced in uniform sizes on the ground. Yet medical and industrial applications have already been found in cancer research and treatment, glaucoma research, and for calibration standards in medical and scientific equipment. The continuous flow electrophoresis system, built by McDonnell Douglas Corporation, is a prototype of a production unit to purify material for the treatment of disease. The process separates substances according to their electrical charge. Hopefully, yields from the production unit will be high enough to make the product available to a mass market in the future. Results from the prototype's first flight show that a very thin, yet highly concentrated stream of protein substance on the left was separated from red dye on the right. The thin protein stream, only a portion of which is shown here, is actually over 43 inches long and is 300 to 400 times more concentrated than yields obtained from the same process on Earth. The continuous flow electrophoresis system represents the first commercial use of Shuttle by private enterprise under a joint endeavor agreement between NASA, McDonnell Douglas Corporation, and Ortho Pharmaceuticals Corporation, a subsidiary of Johnson & Johnson. A unique opportunity to put small, self-contained payloads aboard Shuttle on a space-available basis at a very low cost exists in the Getaway Special program. After proving its flight readiness on Flight 3, the Getaway Special was fitted with 10 experiments built by science students from Utah State University and flown on Flight 4. Deposits for Getaway Specials on future flights, private enterprises' interest in flying payloads on board Shuttle, missions planned into the next decade, all reflect the confidence this nation has in the space transportation system. All objectives of the flight test program were achieved. 2 of the most significant events were not planned. Just prior to the 3rd launch, tons of landing and recovery equipment had to be transported from California to New Mexico, a 1,000-mile journey, because heavy rains in California prevented a landing there. An entire encampment had to be built at the New Mexico landing site, Northrop Strip, and the task had to be completed within 4 days. Just prior to landing on the same mission, only 1.5 hours before touchdown, an unexpected sandstorm blew into the area.
As you could probably surmise, the winds have been coming up all day. It was still acceptable until his last pass, but during John's last pass, the visibilities were unacceptable and the turbulence was severe. So it's not a good day, and we're going to wave off for 24 hours. Over.
Plans were implemented immediately to stay on orbit an extra 24 hours.
We've had a good drill.
The flexibility to remain on orbit until weather conditions improved and land at an alternate strip could not have been demonstrated by previous spacecraft. Only the Shuttle has that capability. It meets a need, providing access to low Earth orbit on a routine basis. By launching on time, serving as a platform for Earth observation and space observation, deploying payloads, operating in extreme temperature differentials while on orbit, providing ample living accommodations for astronaut crews, landing on lake beds, or concrete runways. As President Reagan said, the end of the orbital flight test program marks our entrance into a new era. The test flights are over. The groundwork has been laid. Now we will move forward to capitalize on the tremendous potential offered by the ultimate frontier of space.